All right. Just like Anders, I did not find any good jokes to start with, but while skimming through some articles, I found a nice fact about Thomas Edison, known also as Mr. Bulbs or Mr. Lamps. And did you know that Thomas Edison had 49 patents related to concrete? We all know Thomas Edison, that he was the person that invented the light bulb, but he actually had patents from cement processing equipment, waterproofing cement bait, and even mold for single pour concrete construction. He also envisioned a future with concrete houses, concrete furniture, and even concrete pianos. And this concrete furniture and concrete pianos is something that is interesting from a Betolar point of view, because our history actually started with the production of concrete furniture, such as tables and chairs. So my name is Hassan Raad. I work for a company called Betolar as an R&D director, and I am the person responsible for the product development part of the equation. I have another colleague who is taking responsibility for the material research ecosystem. Just a couple of words about Betolar as a company. Betolar is a Finnish pioneer company in materials technology. Our story began with a bold experiment to replace cement used as a raw material for concrete with a side stream based material. If we look at Betolar as a running track, it can be divided into three phases. We have the product development phase, we have the commercial viability, also known as proof of concept phase, and then finally we have the commercialization phase. If I pinpoint just a couple of important dates, 2016, the company was founded and has received considerable media publicity in the recent years. Sitra has chosen the company as one of the most interesting circular economy companies in Finland in 2019. And in 2022, the company has moved strongly into the commercialization phase. We had our first partnership agreements in Denmark, in India, and eventually also this year in Vietnam and Indonesia. And in 2021 also we were listed in the Nasdaq First North Growth Market. The fight against climate change has been discussed about for a long time, but the interest in low carbon construction has only really picked up in the last year. And maybe the main reason for this is that probably the strengthening of the sustainability perspective, especially at the property owner contracting level, so people who are doing these decisions, as well as the legislators' signals about upcoming restrictions on the carbon footprint of construction. So we have seen a very different or a very more dynamic evolution towards the sustainable construction only recently. The construction industry is one of the most polluting sectors, creating 20% of the global CO2 emissions. And we can see here in the slide that 8% is coming from cement. However, we have to bear in mind that this is clear that this very usable material is difficult, if not impossible, to be replaced in all cases. So it's difficult to get by in today's world without concrete. And when we use the concrete poorly, the concrete is considered to be the bad guy, but when used well, it solves many of our society's needs. The second challenge is connected with the inefficient utilization of industrial side streams. So as we saw in the Tapojärvi presentation, that most of these side streams end up in the ponds and landfills, and because they're hazardous, they pose a great risk if leaked into the environment. I will pick one of these side stream tailings. More than 1.2 billion tons of deposited tailings waste exist in the EU area and billions of tons worldwide. So the amount of tailings grows every year because there's new metal production demand. Betolar's technology enables concrete manufacturing without cement. So nevertheless, our main assumption is that the material's durability and strength are comparable to cement-based products. And the solution utilizes a wide range of industrial side streams produced by energy, steel, paper, and pulp industry, and also mining. Here we can see in different colors the areas we are currently working upon. So the yellow ones are pilots that are conducted, and green ones are where we have commercial or strategic agreements signed. And in the circles, you can see these players that, or the producers that we have been doing cooperation with. Here's a depiction of the application areas we have been recently piloting with different customers in different parts of the world. So the products are produced using different manufacturing techniques. We have dry pressing, we have melting, we have wet casting, dry casting, semi-dry, with various future requirements, such as, let's say, impact resistance, weight, long-term durability, aesthetics, water permeability, sulfate resistance, and so on. And this is done using various raw materials such as tailing sand, alite ore, and many other side streams or precursors. Just a maybe complicated looking slide that it's supposed to be a simplified slide that might maybe look like a vomit. It's just depicting the journey that goes from laboratory to factory scale. So first we analyze the raw materials that are being currently used. We identify the commercially available side streams close to the customer, and then we propose new alternative recipes. Then we evaluate the suitability of the geoprime solution in lab scale, and then eventually we move into piloting, generating the first minimum viable product, the MVP. So through the pilotings, we aim at getting maybe 1 to 3 products that fulfill the basic requirements. And after that, we choose out of them the alternatives that could be tested in a big factory scale. I remember when I was invited to this webinar, something about standardization was hoped to be discussed, and how do we cope with the standardization and approval aspect. When it comes to standardization, at least in most parts of the world, the harmonized standards do not recognize binders such as side streams or slags or fly ash, or even materials such as alkali activated materials or geopolymers. However, there have been many examples, like in China and in the UK, where there are technical specifications such as PAS. You probably have heard PAS document, or publicly available specification document that have been generated for alkali activated materials and geopolymers, but to some extent they cannot be used for CE marking a product and placing it to the market. So in some areas these do not have official status. And the ultimate target is, of course, to someday have geopolymer products or alkali activated materials that could be CE marked and placed in the market in the whole EU area. But we all know that the EU standardization process it's really jammed and stuck, and that might take many years, up to 5 years or even more, to get this kind of standardization. So there could be also some other alternatives that we can look into. One alternative is to handle this in the European market, is to have a European assessment document, an EAD for short, which is a harmonized technical specification developed by the IOTA as basis for the European technical assessment for the ETA. So in combination with the ETA, the EAD provides manufacturers with a way to CE mark for construction products that are not fully covered by these harmonized European standards under the construction product regulation. I would like to highlight one project, or maybe two, within this slide that we have been working on, that is exploring the possibility of using this slag that is purified from vanadium, which could replace more than 10% of the cement used in Finland. And we just signed a letter of intent with 2 Australian vanadium recovery companies. One is called Raad, and the other is called Vanadium Recovery Project Limited, which is also known as VRP. The idea is to start to research collaboration to develop the process at the plant in Pori, Finland. We all know that demand for vanadium is growing rapidly because of vanadium electrolytes that are used in, for example, lithium batteries for electric cars and batteries for wind and solar power plants. And the planned plant will be internationally significant producer for vanadium. Its estimated annual production is, if I remember correctly, around 9,000 tons, which is about 5% of the world vanadium production. And another project I would like to bring into your attention is we have signed a development cooperation agreement to drive low carbon construction with Consolis Parma, which is Finland's leading manufacturer of precast concrete. And the aim is to test various new additives in the industrial manufacturing of precast concrete elements and to significantly reduce emissions from the manufacturing phase of products. And we have started to we have commonly decided to start with the hollow core slab development together. Finally, I would like to give a short overview on what happens to all of this data that we are gathering from the research pilots and factory trials. So we have a lot of pilots. We could have up to 30 to 40 pilots per month. There's a lot of data generated from there. And the idea is we want to utilize predictive modeling techniques that use existing data to build or train a model that can predict outcomes from new data. And the idea is to just make this whole process more efficient, more agile, to be able to serve the customers in an easier way. Because at the moment we have to do, let's say we have a new side stream, we have to study the side stream, do XRDs, XRFs, and other analysis, and then do some kind of lab tests, and then see that is it technically possible to produce with that, and what happens if we add another precursor to it. That would mean another new tests, and these tests could take up to months, and in worst cases up to years, especially when we do the long durability tests. And this can be done by a 5-step process. So we have to first have the data collection, data mining, then we evaluate the model, we have the predictive model deployment, and then eventually model tracking. So this can be considered as a nonlinear model, which is modeling of phenomena, which is independent variables affecting the system can show complex and synergetic nonlinear effects. So let's say a customer contacts us and they say that we have this slag, this fly ash, and then this precursor. And we want to make a recipe that is the most cost efficient. We want a compressive strength of 50 megapascals, and then we want sulfate resistance and also chloride migration to this extent, and no efflorescence. So with this predictive modeling, we can use all of this data that we have generated from the pilots, factory trials, lab tests to have this so-called non-linear conclusion, and avoid having these enormous tests to be done. That's about it. I hope I'm in the timetable. If you have any questions, please don't hesitate to type them in the chat. I'll get back to you as soon as possible. Thank you very much.